The universe is much bigger than any human can imagine. Exciting discoveries of new worlds have been made in the last decade. Just this year, NASA confirmed the discovery of more than 5,000 exoplanets, or planets outside the Sun. They range from super-Earths to gas giants like Jupiter, ice giants like Neptune, and other distant planets. Although planetary scientists have discovered many of these strange places, it is believed that there are more than 1 trillion exoplanets in our Milky Way alone. Scientists have just discovered a planet so large that it easily dwarfs the size of our nearest neighbor. Since its discovery, the huge superplanet known as B Centauri b or Binter b has challenged the knowledge of astronomers and scientists alike. This large planet is located around a massive and extremely hot star in an environment previously considered too hostile for planetary development. According to the European Southern Observatory, which photographed the planet from the Very Large Telescope in the Chilean desert, no planet has been discovered around a star more than 3 times the size of the Sun until Binter b is one of the most massive planets ever discovered. An exoplanet outside our solar system 10 times more massive than Jupiter. Mark Janssen, professor of astronomy at Stockholm University and principal investigator of the study, said that this discovery completely changes the picture of massive stars as planetary hosts. A very large and hot B-type binary star in the constellation Centaurus is the core of this solar system. It produces significant amounts of high-energy ultraviolet and X-ray radiation, which strongly affects the surrounding atmosphere and should prevent the formation of planets. It was once thought that large planets would be incredibly difficult to develop around B-type stars, as they were thought to be quite corrosive and harmful. In this harsh environment dominated by intense radiation, everything is overwhelming. The stars are bigger, the planet is bigger, and even the distances are bigger. According to the research, the findings suggest that planets may exist in star systems that are much more massive than previously predicted. B Centauri b has one of the widest orbits ever discovered and is 100 times the distance between Jupiter and the Sun. The survival of the planet probably depends on its great distance from the core star. Janssen predicted that the time required to search for planets around high-mass stars in general will increase, both to find them and to define them to determine more precisely how they may have formed. While we wait for more discoveries, let's look at another massive planet 9 times the size of Jupiter that formed violently. In general, food preparation can be compared to how planets form in our universe. Ingredients and cooking methods used to create the planet are subject to change. Scientists using the Hubble Space Telescope discovered the planet because it was experiencing a disk instability, a violent and dramatic event that has been compared to a lightning strike. In this approach, the protoplanetary disk orbiting the star collapses under the influence of gravity and breaks up into one or more planetary mass fragments, rather than evolving over time from a small core gathering matter and gas into a planet. Hubble's resolution and lifetime proved to be missing pieces of the puzzle as astronomers searched for definitive evidence of this process as a likely candidate for the formation of Jupiter-like planets. The young star, thought to be only 2 million years old, is surrounded by a protoplanetary disk of dust and gas around which a distinct spiral structure rotates. This is the location of a recently formed planet, roughly corresponding to the time of formation of planets in our solar system. The solar system is currently 4.6 billion years old. Lead author of the study Thane Curry of the Subaru Telescope and Eureka Scientific said, "Nature is intelligent. It can produce planets in many different ways. The raw material for each planet came from a circular disk. The dominant idea behind the formation of Jupiter-like planets is known as nuclear accretion, a top-down method in which planets trapped in a disk form from small pieces of debris orbiting a star, then collide and coalesce to form larger objects. This core then gradually accumulates gas from the disk. In contrast, the disk instability approach is a top-down model where gravity causes the massive disk surrounding the star to rapidly break into one or more planetary masses as the disk cools. The newly formed planet, known as AB Auriga b, orbits its host star at an incredible 8.6 billion miles, more than twice as far as Pluto from the Sun. It is believed to be about 9 times more massive than Jupiter. It would take a very long time for a planet the size of Jupiter to evolve at this distance. This leads scientists to conclude that without disk instability, this planet could not have formed at such a great distance. It is also in stark contrast to what the generally accepted nuclear creation hypothesis predicts about planet formation. The new analysis combines data from the near-infrared camera and the multi-object spectrograph and the Space Telescope imaging spectrograph. This data was compared with the latest SCXAO planetary camera on Japan's 8.2-meter Subaru telescope above Mauna Kea in Hawaii. Given the difficulty in distinguishing complex disk features associated with non-planets from complex disk features associated with young planets, data from space-based and ground-based telescopes have proven crucial. According to Curry, this system is very difficult to interpret. This is just one reason why Hubble was necessary for the project. The clear image made it easy to distinguish the light from the disk and the planets. The huge disk of dust and gas orbiting the star AB Auriga is almost at an angle to Earth's perspective that nature itself made possible. Curry emphasized, Hubble's endurance was crucial in helping scientists determine the orbit of the protoplanet. At first, he seriously doubted that AB Auriga B was a planet. Archival data from Hubble and images from Subaru were instrumental in changing his opinion. According to Curry, we couldn't detect this motion for about a year or two, but Hubble provided a time baseline. Along with 13 years of Subaru data, that was enough to detect the orbital motion. Olivia Wan of the University of Arizona in Tucson and the Subaru telescope in Hawaii says this result uses both ground-based and space-based observations and makes it possible to use data from the Hubble archive to travel through time. Now that AB Auriga B has been studied at multiple wavelengths, a reliable picture has emerged. This new discovery provides compelling evidence that some gas giant planets may form through disk instability mechanisms.
Gravity ultimately matters because one way or another, the byproducts of star formation are pulled together by gravity to form planets. Astronomers can better understand the evolution of our own solar system by understanding the early stages of the evolution of planets like Jupiter. This discovery will enable future studies of the chemistry of protoplanetary disks like AB Auriga, especially those using NASA's James Webb Space Telescope. On the other hand, NASA's Transiting Exoplanet Survey satellite, TESS, discovered a living city only 33 light-years away from Earth. It has a star at its center, several planets orbiting that star, and at least 2 Earth-sized worlds. According to the researchers who made the discovery, it would take about 330 years to reach this solar system-like region of the galaxy if you could travel at 1/10 the speed of light. Of course, this is not possible for several reasons. However, we can take a very precise picture of this neighborhood using special ground-based instruments such as telescopes and space-based spectrometers, perhaps even the James Webb Space Telescope when fully operational. The host star of the system, called HD 26965, is a relatively small so-called M-dwarf. Based on current knowledge, M-dwarfs are 10 times more common in space than our Sun, a G-type main sequence star, although they are 10 times less massive. About 1.2 times the size of Earth and twice as massive, the inner planet orbits its star every 2.8 Earth days. Another alien world, 1.5 times the size of Earth and 3 times more massive, orbits 5.7 Earth days away. Both are considered stones. According to Michelle Kunamoto of MIT's Kavli Institute for Astrophysics and Space Studies, one of the discovery's lead scientists, both planets in this system are prime candidates for atmospheric studies because of the brightness of their stars. This includes studies that seek answers to questions such as, are there volatile atmospheres around these planets? Are there signs of aquatic or carbon-based species? In other words, does the Earth have a protective layer like the ozone layer and human-like life? According to Kunamoto, these planets are excellent testing grounds for these studies. Before you get too excited, scientists point out that recently discovered rocky worlds are unlikely to be habitable because they are likely too hot to hold water and are very close to their host star. According to the study, the core planet is estimated to heat up to 880 degrees. By comparison, the temperature outside the world is about 548 degrees Fahrenheit. Don't you consider this area non-residential? But if you think you can survive this extreme temperature, we won't stop you. However, the search for habitable exoplanets can greatly benefit from learning about these worlds.